Okay, so we're going to find any vertical asymptotes of the following rational functions. So we begin by finding the domain. So step one is to find the domain. So I'm going to take the denominator of the function and set it equal to 0. It tells me that x equals 0 and x plus 4 equals 0. And from here, I get that x equals minus 4. So those are where the denominator is equal to 0. So I put a slash there. So x should not be equal to 0, and x should not be equal to negative 4. Now, if there are any vertical asymptotes, they will occur at the places where that are excluded from the domain. So we have two possible vertical asymptotes. X equals 0 and x equals minus 4. The next thing that we do is we simplify this rational function. Now, there's no common factors between numerator and denominator. So it is simplified. So these are our vertical asymptotes. So they are the vertical asymptotes. Okay. Let's look at another function here. So here's our rational function. We take the denominator and set it equal to 0. Solve this one factor for x. Okay, so the possible vertical asymptotes are 0 and negative 4. Possible vertical asymptotes, x equals 0, x equals minus 4, because both of these are excluded from the domain. Okay, so my next step is to simplify the rational function. We can see that there's a common factor of x between the numerator and denominator. So if I cancel the x in top and bottom, I don't get 0, I get 1 over x plus 4. Now, so according to this rational function, x can't be negative 4. But I'm okay with x equals 0. So my only vertical asymptote is x equals minus 4, and that's from our simplified rational function. So we have a vertical asymptote at x equals minus 4. Now x equals 0 is x can't equal 0 in the original function. It's still excluded from the domain, but at x equals 0, we don't have a vertical asymptote, we have a hole. So 0 doesn't go into the original the original rational function, but it's not a vertical asymptote. So if you graph this function, you see a vertical asymptote here at x equals minus 4, but not at x equals 0. Okay, so next we look here. Our possible vertical asymptotes is x equals 3, and that comes from taking the denominator here and solving it for x. So if I have a vertical asymptote, it's going to be at x equals 3. Now to determine if it is a vertical asymptote, I simplify g of x. So the numerator here factors into x plus 3, and x minus 3. So we have a common factor between the numerator and the denominator. So this is my simplified form, x plus 3. And since I do not have my denominators 1, with this function, everything's okay. So this is not a vertical asymptote. So I have no vertical asymptotes, but x still can't equal 3. So if I were to graph this at x equals 3, there is a hole in the graph. So when I look at my original function, my rational function, I have, I can find my domain. So here, my domain, I can't equal 3 or minus 3, and that is because my denominator factors into x minus 3 and x plus 3. So if I have any vertical asymptotes, they will occur at 3 and minus 3. So my possible vertical asymptotes are at x equals 3 and x equals minus 3. Now, I see a common factor in the numerator and denominator, so I cancel that out, and I get 1 over x plus 3. So I've lost, in doing that, I've lost x equals 3 as a possible vertical asymptote. So my vertical asymptotes are occur at the remaining values in the simplified rational function. So x equals minus 3 is a vertical asymptote, and at x equals 3, there is a hole. So when we find the domain, those values are either going to have a hole or they're going to have a vertical asymptote. We tell the difference between whether it's going to be a hole or a vertical asymptote by simplifying the rational function. Now, the simplified rational function, we don't change the domain when we simplify it, but we can determine which values have vertical asymptotes and which have are holes. So those are the examples that I had picked out for this. I guess I can do one more. And maybe I can do maybe a couple more. So let's look at x over x squared plus 49. So this has no vertical asymptotes or holes because its domain is all real numbers. So this doesn't factor. Remember, x squared plus 49 doesn't factor. And so its domain's all real numbers, so there's no vertical asymptotes or holes. Last one, we're going to look at the function x plus 7 over x squared plus 4x minus 21. Now we saw this one in the other video when we were determining domain. So I begin by taking the denominator, and setting it equal to 0. So I'm going to determine my domain. This is going to factor into x minus 3 and x plus 7. So I take each factor and set it equal to 0. And I'm going to solve for x. So I get x equals 3 and minus 7. Oops. So x cannot be that. So my domain is x cannot be 3 and x cannot be minus 7. So these are my possible vertical asymptotes. To find out which ones are vertical asymptotes and which ones are holes, I have to simplify the rational function. So I get x plus 7 divided by x minus 3 over x plus 7, so that plus 7's cancel, which means that the remaining factor here, x minus 3, corresponds with a vertical asymptote, and the value that was canceled corresponds to a hole. So my vertical asymptote is at x equals 3, and I have a hole at x equals minus 7.